I'm very excited for another episode of Show About Science. This is your host, Nate, and today we are talking about thermophiles, the colorful bacteria that can not just survive, but thrive in the hottest of places. It's going to be an extreme episode, so stay tuned. Hello, this is Nate from the Show About Science. I'm so glad to have you on the show, Tim, and could you introduce yourself?
Sure, Nate. My name is Tim McDermott. First, I appreciate you inviting me onto your program. I'm really impressed with the breadth of science that this program covers. It's very interesting, and I appreciate being part of it. So, yeah, I'm a soil and environmental microbiologist studying here at Montana State University. And I've been working in Yellowstone National Park for about 20 years, working with microbes, various microbes, but mostly those microorganisms that live in the hot springs that people see when they visit Yellowstone National Park.
So what are thermophiles?
Sure. Well, the word thermophile means hot loving, okay? And so thermophilic organisms, microorganisms, are those microbes that like it hot. So, for example, we have different classifications. We have those that we just refer to as thermophiles. We usually find them in environments of temperatures of 50 to 65 degrees centigrade. Then we have extreme thermophiles that range up to about 80 degrees centigrade. And then any microbe growing in hot springs higher than 80 degrees, we refer to them as hyperthermophiles. And it just reflects the different temperature ranges. And these thermophiles, literally, they like it hot. And so they're not just barely hanging on with their microscopic fingernails, so to speak, but rather they like it there. They love it there. And if you take these microbes out of a hot environment, they either stop growing or they just die altogether.
Where do thermophiles live?
Well, as it turns out, we can find thermophiles in lots of different places, not just Yellowstone. For example, if you, your family, or your friends compost any of the organic waste from the table or your garden, etc., and you put them in a pile, then the microorganisms that are degrading that organic material, through their activities, their biochemistry, they start generating heat. And the center of these compost piles get very hot. And these temperatures start selecting for thermophiles that are already there, but just aren't the most abundant organism in the environment because normally the temperatures aren't that high. But when you put together an environment or a situation such that the temperatures start to rise, then the environment begins to select. And in fact, there's an old saying in microbial ecology, everything is everywhere, but the environment selects.
So why do thermophiles like it hot?
Well, excellent question. So basically, it comes down to a question of the stability of their different enzymes or proteins in the cell. And at what temperature do these enzymes operate most efficiently? And so if you were to purify certain enzymes from these organisms, or many enzymes from these organisms, or any enzyme for that matter, you would find that the enzyme, when you assay for its activity, you measure its activity, you'd find that there is an optimal temperature, okay? And that optimal temperature quite frequently reflects the optimum temperature of that microorganism. And so these thermophilic bacteria, they like it hot because their enzymes like it hot.
Wow. That's a lot, and it's very useful to know all of that. So what do thermophiles eat?
Well, a wide variety of things. And in fact, that's why they're interesting to study. So for example, if you were to go to Yellowstone National Park and you'd walk along the boardwalk at Norris Geyser Basin, you'd see all these beautiful colors. You'd see oranges and reds and yellows and greens, all these different colors people typically think of as geology, okay, or geochemistry. But in fact, these colors are due to the microorganisms that are living in these environments. So, for example, a lot of these very acidic waters that come to the surface, they carry a large amount of iron that is in a colorless form. But the microbes, certain archaea, will oxidize this iron to a form that precipitates and turns yellow or orange. Okay, and so when you walk on the boardwalk and you see these orange colors or brown colors, it's due to these bacteria, these archaea, that are oxidizing iron from a colorless state to form an orange form that precipitates out. Other colors you see are due to hydrogen sulfide oxidation. Okay, and so when you go to a place like Norris Geyser Basin, you'll smell this rotten egg smell, and that's hydrogen sulfide gas that's coming up with the water when it surfaces. And there are bacteria that specialize in gaining energy from oxidizing the hydrogen sulfide gas to elemental sulfur. And that results in these yellowish-white formations that you see along the boardwalk. So they're gaining energy from these oxidations. There are other bacteria that will gain energy for growth from oxidizing toxins like arsenic. And that's what my laboratory has specialized in over the years, looking at arsenic metabolism in bacteria. And so we know that arsenic is a toxin, okay? It will kill people if you ingest too much of it, and it will kill bacteria if they are exposed to too much of it. But if you get just a certain amount, then bacteria can gain cellular energy for growth by oxidizing one form of arsenic to a different form of arsenic.
So, I heard that they can be used in medicine. Is that true?
As we've come to learn over the last 4 or 5 years, microbes are beneficial to the human body, okay? For the longest time, microbes were always viewed as germs, bad, terrible, make you sick. And to be sure, there are a lot of organisms out there, microorganisms, that will make you sick, very sick. However, when people started looking at the microorganisms in our stomach, okay, in our intestinal tract, they're finding that, wow, there's a lot of bacteria there, number one, and number two, they are very, very important to human health. And we're beginning to find that these bacteria in our intestinal tract have a lot to do with stomach problems, perhaps different cancers. We're starting to see relationships between these microbes and all aspects of human health and welfare. And so, yes, there are microbes that are good for human health and medicine and biomedical applications. And in fact, actually, coming back to Yellowstone, by learning about how microbes interact with things like toxins like arsenic, we can begin to understand why some people may get sick when they ingest a toxin like arsenic, whereas some people won't. Okay? And it's very satisfying for me as a scientist to be able to transfer the knowledge and information you gain from work in Yellowstone to the biomedical arena. Very satisfying.
It sounds very satisfying. Do thermophiles get old?
Well, the short answer is no. Okay? And that is because microorganisms multiply very fast. That is, one cell becomes two. The one cell divides, it becomes two. In fact, a famous microbiologist once said, the goal of a microorganism is for one cell to become two cells. Okay? And so, depending on the microbe, like E. coli, Escherichia coli is an organism that we have in our intestinal tract, as one example. Under optimum conditions, that microbe will divide in less than a half an hour. Okay? And so, from when that cell first divides and then divides again, then you'd say that cell is 30 minutes old. And all of a sudden, we have two new daughter cells that live for 30 minutes, and they divide and form two more cells. And so that's an interesting question that you put. And sometimes the cells grow very, very slowly, depending on their environmental conditions. And so maybe the lifespan of that single cell before it divides may actually be days in length, as opposed to hours.
So, how do thermophiles survive in hot temperatures?
Well, it's because the enzymes and proteins that I mentioned a few minutes ago, they're stable to these high temperatures. Okay, and that's an important feature of these microbes. At one time, scientists did not believe that anything could survive in these very high temperatures. But with careful analysis and experiments, people began to show that, wait, that's not true. In fact, not only do they grow in these environments, but they grow and they thrive in these temperatures. It's because their proteins are stable to these high temperatures and don't degrade. Let me give you an example of denaturing proteins. When you fry an egg in the morning for breakfast, how does that egg change?
It disintegrates into stuff that you can digest.
Well, kind of, but that clear yolk of an egg turns white, right? And that's because when you apply heat to those proteins, they denature, and the egg yolk goes from clear to white. And so that's an example of how temperature can cause certain proteins to denature. But in these microbes that live in these environments, that doesn't happen. In fact, one of the most famous proteins or enzymes that we know that came from these high temperature organisms is called Taq polymerase. And this enzyme operates like a molecular Xerox machine. That is, we can use it to amplify DNA, okay? And this one enzyme has turned out to be so important that it completely revolutionized every aspect of biological sciences, including the biomedical sciences. If we did not have that single enzyme to help us as a tool, then progress in medicine, for example, aspects of the human genome sequencing project, it would not have happened. Without this little itty-bitty enzyme from an itty-bitty organism in a hot spring in Yellowstone National Park.
Thank you for being on the show.
You're very welcome, Nate. Thank you for asking me to participate. Have a great day and stay warm in Chicago.
I will. The temperature's definitely extreme outside. Okay, there you have it, folks. The show about science is complete. Dad, you can shut the recording off. For the newest episodes of the show about science, download the Pin app or go to pinna.fm/promo.